Okie doke, let's continue. Last time it seems like operator overloads can't be in a namespace, I guess? Because if it's in a namespace, I can't access it. I don't have the history to my previous files. I should have version controlled, honestly. I should do that now. Well, I guess it's a problem if I delete the whole file, though. Maybe it wouldn't help. Because I'll create header files and CPP files, and then I'll delete them. So that I can run them, because otherwise I have to blank them out to make sure they're not used, and then I just end up with a fucking graveyard of empty files. So, screw that. I'll keep going. And I swear it wasn't namespace operator overloads, but I'll assume that that's what happened. Because here, we can have everything in one scope, or at least everything in global scope, and then we're cool. It just seems like we can't use these guys, excuse me, like normal, which is annoying. String S? Why the fuck would you call it S, bro? Nobody knows what it is. Yep, we can do the same thing. Cool. Yep, we can set it to fail, and then that way we evaluate it, it has failed, and then we can clear it later, which I guess sets the state to not failed. And say your pet's not valid. We did that. Yeah, makes sense. Few differences. First, we have iStream versus OStream, so we get a reference to that object, because iStream is an object that exists. It's not just a, it's not a fucking, well, iStream is a class, rather. It's that character input is an object. So character input, we need a reference so that we can get character input specifically as the type. Instead of OStream reference. The pet parameter is non-const because, yeah, it makes sense, so that we can actually change it. Well, I mean, in the other case, the point was that it was a const reference, that we were passing. Oh yeah, I guess so. Because we could pass it as, oh, well, before I just left it as passed by value, honestly. I didn't even do a reference, I don't think. Yeah. So now we actually have to modify it. Pet is a needed out parameter. I talked about that earlier. If it was a value parameter. Yeah, exactly. And then it wouldn't actually change it. Yep. Agreed. Makes sense. We use that to input a standard string. Well, to input to a standard string. Or extract value to a standard string. If the value of the user enter. Wait, and why are we doing standard character input? We're not doing. I guess we just want one name, one word, no spaces, so we don't want getLine. I think I did getLine. Maybe I didn't. I don't remember. Then we can assign it the appropriate or hold. And then we get the value. So we get the value from the user, and then we check to see if it's valid or not. If it's not valid, we can handle. We have to put it into failure mode because it's not going to fail to extract. It extracted. It just happened to be wrong. So we can put it into failure so we can evaluate it. Or we can just make it so that you can't fail. So that you go until it succeeds. I'm done with fucking olives, and I'm done with this new flavor shit I've been doing. I've been making the same tasting shit for a little bit. It's flavorful, sure, but I get bored of it. So I did the same thing with fish, and I couldn't eat it all because I'm just not hungry enough for it. So I'm gonna finish my lunch and dinner later, but I need to do some sort of like lemon-based sauce and not fucking olives and shit. This is the state that it goes into when it fails, but it didn't fail. We just do it so that we can evaluate whether it succeeded or not. That way we don't have to, well, yeah, because it returns standard character input, the object, or rather a standard input stream reference. And it's not going to fail, it's going to return it, but we can evaluate it though. Kind of like an optional. It's actually really similar to an optional. We output standard character input, and we don't really give a shit about it, but we can evaluate it to see if it was successful. We use standard array to make input and output operators less redundant. Oh, because if we add another numerator, then okay, so we what create an array of the enumerations or of the enumerators. That way we just pass that in, and it checks to see if it matches any of those instead of having to make it check another thing. We can add a loop probably and check through them all. Input and output operators less redundant. Huh. Where's the redundancy in here? Not sure what else we could remove, but I could see part of that. Alright, scoped enums. Okay. Enum classes. They're distinct types. Oh, wait, hold on. Here we go. Unscoped are distinct, but they're not type safe. Meaning that what they aren't distinct from integer values. Is a scoped enum the difference? Meaning that what it has its own scope and the value only exists as it does, and there's no 0, 1, 2 thing. Maybe. Instead of the case where we say color and fruit, and we say, oh, the problem is that we're saying color and fruit, red and banana are both 0, and it'll print color and fruit are equal because it's doing an integer conversion because you haven't trained it already on them. Yeah. So you'd have to do like operator equivalence and then disallow calls to those two. Like I can't assign a value of banana or of a value of fruit to a thing that is an object or that to a color. I can't assign a fruit value to a color object or vice versa, but I can equate them, and it will yield two integer conversion or an integer conversion, and then some things could be equal. It doesn't, so it then tries to find a match. Makes sense? Yeah, eventually integers work. Makes sense. Well, yeah, we wouldn't want that. With standard enumerators, we would have to explicitly, I don't know, modify the operator equivalence and the operator greater than and less than and all that so that we can't even compare colors to fruits. Well, yeah, I mean, put them in their own namespace, but if you put them in global scope, then they put them in the global scope. Yeah. Makes sense that scoped would have them in their own scope. Curious to see if they don't actually have integer conversions, though. Enum class. Oh, shit. They won't implicitly convert integers. Okay, good. And they're only there, so we actually have to access color to get red or blue. Okay. Feels like there's a bug or something. Guess not. Okay. Doesn't know bandit, but if we do. Oh, it's actually stopping it right here. Can't equate them. That's cool. A binary guy to a type acceptable. Basically, there's no conversion or any way to compare these guys. Cool. So they're type safe, meaning that they're unique individual types, kind of like a Boolean, but even without implicit conversions. Yeah. Yeah, because they're officially distinct types that don't implicitly convert into anything that they can change. The class keyword along with static. Most overloaded keywords. An overloaded keyword? And different meanings depending on the context. Gotcha. So this is an overloaded one where the word is used with an enum and an identifier? Yep. Yep. I don't know about reduce. It seems like it removes because if we have two different scoped enumerators, they can't be compared. They don't put it in the global namespace. They're enumerators, so we're just good. Or you do it the same way you were doing it for unscoped enumerators. Well, enumerations. Red doesn't work. Color red. Oh shit, we can't even. Oh well, yeah, because before it would implicitly convert to an integer, and it would print, but not how we wanted it. Now we can officially. These seem better. But you wouldn't be able to have a hierarchy where one enum is greater than another. It seems like they don't convert to integers, so we can't say, oh, if blue is greater than red. Can we evaluate them like that? Enum class color red, blue. Let me say if color red is greater than color blue. Empty controlled statement, hold. If const expression. Oh, so maybe it's actually going to say false and we can compare them. They just don't convert to integers. Because I wanted it to still be the case that we could compare them to each other. Because they're the same type. And it would be nice if we could say, okay, hey, blue is actually greater than red. Oh, so they actually do have these numbers, but they don't implicitly convert. But I'm wondering how the conversion is even possible then here. Right. Or does not. Okay. So they can still be compared like that to each other. I mean, I would still put it in one if it had other related stuff for it. That way we go into that one namespace to get everything. Here's the key. Yep. I'm thinking about having a struct and overloading operators inside of it, maybe. I don't think they still need to be known in global scope. Like if we would enum for like, I don't know, the users the character classes RPG class, like the actual game class, and you choose it. Choose which class you're putting levels towards. And maybe you have a primary and a secondary, something like that. And we want to be able to print those. I guess we could just have custom functions that print it, or to get the name, and then we can print it that way. But we can static cast it, makes sense. Oh. Standard 2 underlying, meaning it converts it to the underlying one. Oh, so instead of doing to end, if we know the underlying for the enum class, then we'd be good. Gotcha. Okay, so you can still do the underlying type like normal. What do I cast it to enum? Oh, we're casting the integer to a scope. Okay. Oh, so if the user put the number, then we can cast it to that instead of just assigning it because it won't implicitly match. I'll be back. Cool. Excuse me. 2 underscore underlying. Okay. To include utility. Excuse me. Are you tripping? Oh, it's C++ 23. Not gonna work. Doesn't exist. Hmm. Oh, well, sure, I would have to. I gotcha. It's not even what I wanted to do. In this case, it's actually out of range. Oh yeah, true. We can't even implicitly. Hmm. We could store it as 3. And if we. Yeah, so there's no implicit conversion. So it actually holds the value, it's just not in range, which is funky. What about C++ 20? So same thing for C++ 20 as well. Okay. I don't know what the base shit is. Okay. Hmm. The fuck? Everybody's pasting everything in the world down there. So we could do. I'm thinking we have a template type name for the operator. That way we can pass it multiple enums. And am I returning the underlying type of it? No. Oh, well, yes, but we're letting it be auto. Okay. So what if we have then... Oh, there we go. Oh, so we can return that of the type. And we... Wait. We're doing a static cast of... Oh, wait. Oops. Oh, wait. Hold on. T. What do you mean? We're returning a static cast... Oh, I guess... Of X? What? Well, I don't want to return... Can I just return X then? And it returns the underlying type of it? Oh, and I guess I didn't need to static cast it to its underlying type. Like that. Fuck type deduction, maybe. Maybe not. Excuse me. What? The fuck are you saying? There it is. I just fucked up the syntax. For static casting, x to be hold. Now, if we said good. And that's if we needed to get the index of it. So then maybe I need to compare it to something else. Okay, we'll compare it to the types of cats. Oh, well, this is not a cat. Two and one? Yep, cool. Excuse Boston versus shit. Yep, makes sense. Cool. So we can take scoped enumerations, which have their own scope, their own namespace scope. Do not put their enumerators in the scope that the enumeration is inside. So it's not like an inline or an unnamed namespace where they put their shit on the outside scope. Or I guess an inline is not true. Never mind. Inline is for versioning. We make something inline. Hold. No, never mind. They both do the same. It's just that inline takes priority over unnamed. So if there's a shadow, then inline will have stuff that's its stuff will not be shadowed. So we put the older version stuff in the unnamed, and then we use the inline for the main stuff. I think so. Well, yeah, because the unnamed has internal linkage, so if any other files are using the unnamed stuff, then they won't get it. Hold on. Why did this end? Who knows? Okay, so scope denums. Okay. We can convert them. We can do operator overloading. We can overload plus, we can overload insertion and extraction. And we do that so that if we get them, we can actually convert them to strings, because enums are not inherently strings. Excuse me. If I had a struct or a class, excuse me, with multiple of the variables inside it, and I needed their names, I guess I'd have to have a switch case to output the yeah. And then you could overload an operator that you want to be the get name guy. Or you could just have a bunch, maybe there's a built-in thing to get the literal name of the variable. Excuse me. But we can always, not always, we can't always use a switch case, but we can use if else and switches to get matching strings to print the names. Okay. Okay. Alright, so in this case, what does he do? He does an enum. Okay. Ugh. So we could say, oh yeah, true. It should be const expression. That's right. I don't know about no except. Does it mean it's gonna throw an exception sometimes? Oh, we're returning a cast. Yep, exactly. That's the same syntax I had to figure out. Or we're using a template type. We're casting to the underlying type, but the underlying type has a template type that it's looking for. And then we return the value. Yep. Same thing, I just didn't have no except. I don't know what that is. And const expression, which I forgot. Oh, and you could convert one to the other. So you could say animals elephant and plus to get the integer. Oh, that's the whole point of this. Okay. Syntax looks weird because you're putting it right before the scope that we're resolving it from. In this case, the enumerations name. So it's weird. I almost prefer doing plus and then putting it all within a parentheses to look better. I think it improves readability personally, but could be wrong. Oh, and then instead of using namespace, we can do using enum to get. Oh, I guess so, right? Because we have to say using namespace something, but now we can do using enum something in order to just get the values and bring them into scope. Just like a namespace, we have to bring them into scope. They just aren't inherently in scope. Cool. Nice. Yeah, that's right. Yeah, instead of having to do, oh, color blue, color red, color this, color that, color this, we just say, hey, using enum color, red, blue, yellow, green, purple, pink. So much for the lyrics, bro. Oh, shit. Oh, I posted in here. Jesus Christ. Okay. Oh, true, because then you could do it in a switch, huh? Well, I guess you couldn't do it in a switch, but you could do it before a switch in a function. So you could say using enum color in there, and then boom. And maybe that's better. I don't know. I don't know if it's actually better. Because what happens if color gets moved into something else? Now we have to say using namespace they are using some. Well, yeah, we'd have to say using something color to then get it instead of just using color. Curious to see what the best practice is. Is there one? We'll see. Oh, quiz. Nice. Makes sense. We could say, you need to sit the fuck up. Sit up! Alright, let's go. What do I want to actually use an enum for? What's a good example? Enemy types? Sure. Enum class, enemy type. Aggressive, or we could say hostile, neutral. Well, I guess enum class, excuse me, character type or creature. Hostile, neutral, friendly. Okay, and we could say, what's the point of this? Oh, to get the string. All right, well, oh yeah, and right here. Boom. Okay. And then maybe we could do, let's try some operator stuff real quick. Boom. Can't do shit there. Can here. Boom. Like a switch case. I do not like that shit. Case this, return this, case this, return this, case this, return this, case default return. I mean, I guess it's not bad. But then I have to, well, see, does it even tab out nicely? I guess we'll find out. It actually does auto space. That's nice. Oh. I guess it's not bad. Instead of having double the lines, maybe. Yeah, I agree. Example, it's an enum class, so we can normally do it with a fully qualified name to actually get into the scope and get the enumerators, but now we're using the enum so we can just get them because they're in scope now. Yep. Okay, define an enum class named animal with a bunch of animals. Write a function that takes it and switches. Yeah, exactly. Switches on it as a standard string view. Sure. Bop, and then another function in print number of legs that uses a switch based on the. Wait, what? That's easy. What? Hold. Call print number of legs with a cat and a chicken. So if I call print number of legs with a cat, oh, point is that hold on, so we have an enum class, sure. Oh fuck. We return the name. Oh, and the point is that this one we would return it and say the name, if this, that name. Oh, okay. Okay. Alright. So make an enum class. Oops. Oh, class is different. Enum class called animals. Okay, well I guess it's an animal. It's the value of animal. Pig, chicken, goat, cat, dog, duck. Excuse me. Namespace, animal functions, and then we'll say and we need a standard string view returning function called get animal name. Yep. And it takes an animal, this animal, oops, switch. Oh, now we could say using enum animal, and then we could say switch this animal. Oops. Animal. Case pig. Returns pig. Oops. Turn pig. Case chicken. Oh, I guess I can tab it again. Return chicken. Case goat. Return goat. Case cat. Return cat. Case dog. Return dog. Case duck. Return duck. Default. Return invalid animal. And another function gets animal name as string from enum, or convert enum to string name, or well, okay, or get standard string view name from enum. Sure, we're only having it in this file, so may as well make it static, I guess. But then we could also have another one, and it's called print number legs, and it's a void print number legs, void print num legs, print number of legs, and it takes an animal, and then what? It has another switch case using enum animal. Oops. So we could switch on this animal. We could say case pig. Hello? Get, excuse me, get animal name. I mean, I guess we could do this instead of just, I mean, I could just overload it now. Why not? I'm not sure how the operator overloading part will work. We might have an issue here because it's only going to be overloaded later. But I need to have it later because the overload is going to call get animal name. But output was for some reason fine here. So returning. Fuck. No, this is shit. Alright, returning a what? Oh, no, okay, gotcha. Standard OStream reference. Operator insertion. Standard OStream reference. Animal. This animal. Output device. And we'll say output device get animal name this animal return output device. What's the issue? Well, here and we could just say it outputs Okay, so it'd be cool. This animal has 4 legs. Case chicken. This animal, oh, well, we could just say we could say default is invalid. This animal has oh, it's print number leg. Yeah, it is. Excuse me. How do I want to do this, huh? A something has 4 legs, 2 legs, case goat, 4 legs. Oh, and I could actually do some fall through here in a sec. Cat, 4 legs. Case dog. Oh wait, what am I doing? 4 legs. Case duck. 2 legs. So we could say is that it? That's the only issue? Where are you seeing that? 47? What? Okay, it's just fall through. All right, so we're gonna do I'm taking chicken and I'm putting it there. I guess I could just do hold. All these are that many. Is that 56 and 61? Oh, well, this needs to be break. What are you saying? 78, bro. What? Wait, that was right. Oh, and then this guy needs to break. And then this guy needs to break. Okay, there it is. Nice. These four have 4 legs. These two have 2 legs. And then we're going to say animal. My animal. Animal. Cat. Then we're going to say animal functions. Print number of legs. My animal. And then we're going to do the same thing with another. What is that? A chicken. Oh, hold. Oops. Cat has four legs, a chicken has 2 legs. So here's the way to get the name. And I mean, I could have a whatever has 4 legs. The point here is an enum class named animal that has these animals. We get animal name that takes an animal parameter, and we get the name via string view. Cool. Now what if we do invalid animal? There it is. The problem is this part. So then am I redundant or do I catch it early? Yeah. I really don't. Do I do the redundant shit? Well, I guess it's honestly not even that bad now because I can use follow through. This animal has 4 legs. And then has 2 legs. And then we could say invalid animal is invalid. Or we could say invalid animal cannot determine number of legs. And then here we could say invalid animal value, no name. Or what? Oh, oops. Oops, there's no space. If I'm doing 7, what is it getting to print? It goes from cat down there and prints. Like what? Well, the point is that when we print this, we're using this guy, which gets the name and prints it. Okay. Oh, so the point is it goes and determines it, and then it goes up and, okay, makes sense. So we go and we say, okay, what's the animal? I mean, if we're doing this, we may as well, I don't know, but. A something. What's the something? Oh, it's a cat. There it is. A cat has 4 legs. Return to stream. Boom. So that finished. That's cat. Has 4 legs. Break. Return to main. But now we're doing. It's defaulting to pig. So we're converting 7 to an animal, and the default is pig. So 0, 1, 2, 3, 4, 5, 6, 7. We don't have this. We only have 0 through 5. So we have 7, which defaults to pig. It's undefined, I think, but we got pig in this case. Oh, and in this case, it's going down. Wait, why did it? Wait, what? What did it do? Hold. We go down and we say error, invalid animal. Can I? Oh, because we don't even. I gotcha. Okay. We print legs. And we print this straight away. We automatically know the error is first caught here. But if it somehow goes to here, then we get the issue. All right, cool. Does that satisfy everything? Takes an animal parameter and uses a switch to get the name as a string view. And another function that prints the number of legs. Oh, well, I guess you could say another function that to print the number. Are you to print the number? The number of legs? I did not get ice. I don't know what that was. Am I good? Hold on, let me check to make sure my pasta didn't just fuck up or something. But it couldn't have. I'm good. Okay. Like, how would I want to do that? I mean, wouldn't I just call one with the animal and then it would get the name and then it would get the something else and do both? Excuse me. Or, well, I mean, I guess I just have an animal and I want the number of legs. And it checks to get the name, because otherwise, I mean, we could do that here too. I'm curious to see how you would do it. Oh, wait, no. Oh. Yeah, he did fall through. Makes sense. But yeah, but you're gonna get warnings for that, bucko. Alright, let's see what happens. So all you're doing is printing and printing. Cool. This is exactly what I did in the beginning. Yeah, I guess you could do that too. That's how I had it in the beginning. Am I tripping? What is the issue? What? Oh, oops. Oh, hold. Excuse me. Has. Oh, there we go. Yeah, I guess we put a space there so I don't space any of this, and then we'll space this out. And then we could do animal functions, print number of legs, animal, cat, animal functions, print number of legs, animal, chicken. Alright, something has something legs, a cat has 4 legs, a chicken has this many legs. Cool. So we're doing fall through on purpose here, so that they all, because 4 and 2. Versus here, we're doing it and we're not explicitly saying the follow through, so I'm getting errors. We could do using, that's what I did. Cool. Oh, members, nice. More than one variable to represent something of interest. Well, yeah, that's what I'm thinking with the card game, because I want for the card little test game. I think a player needs to have different cards. So a player has a hand of up to 5 cards, something like that, and then I have functions in the player to get them, or I could just have a function that gets the cards and I pass it to the player. Or it could be a member function with the, yeah, because we shouldn't be getting cards of anything else, so it should just be in the struct. Like if I'm only ever going to attack a character, it should be character.apply damage. It should never be like brick.apply damage, unless you can apply that. Then in that case, maybe you do have apply damage, and it's a parameter that, or it's a function that takes an object or a character. Meaning an object like a literal physical object, a world object, and a character. More than one variable to represent something of interest. Like a fraction with a numerator and denominator. So it's one thing, but it has multiple pieces. Like maybe a character and it has health of his arm and his head and all this kind of stuff, different stuff. Alternatively, write a program where we need to store information about the employees in the company. So we could have a company object that has all the different stuff about the people. Or for each employee, you have different stuff. So we could have struct employee, and then it has a standard string name, and then it has a standard string title, and then are these all standard strings? It's kind of expensive, maybe. And then an int, and then the const expression ID, maybe, and then a const expression manager ID, etc. Yeah, and the problem though is there's nothing that ties that. Like if I had one object with these, and I had someone else that has all of these too, I would have to make 12 different variables for that person too, instead of just having, yeah, here's 12 more for each. Instead of just saying, hey, there's one object, it has all 12 of these. That way, every employee that I make, it has its own 12. So sure, yeah, maybe we need 12 different things to store different unique values. Maybe not though. Yep. Oh yeah, true. Instead of just passing one guy that has them all, and you pass them as one total thing. Is there a loose string somewhere here? Something is. Oh, I guess I have longer hairs here, so maybe I'm just getting used to that. Yep. Not to mention, it's not necessarily unique, even if all that stuff was different. Versus having a separate object itself, maybe that would tell you. Yeah, we have to update 12 where they are. We have hundreds of variables for all these people. Yeah, fuck that. Two compound types. Structs and classes. Okay. Structure. Program defined. Bundle multiple variables together into a single type. Nice. Okay. Okay. Tell the compiler what it looks like before we can use it. Boom. struct, we have called him employee. Each thing, yep. He's got 1, 2, 3, etc. Data members or member variables. So these are members that belong to the object, the struct. Okay. Excuse me. A member is a variable, function, or type. Anything that belongs to a struct. And it must be declared within its definition. Member. Anything that belongs to a struct. Which so far is a variable, a function, or a type, meaning an enum. Seems like. Oh, after each, for each one. Okay. Well, what fucking time? How long am I supposed to be going? Thought. Default member initialization. Like I just create it with nothing and then they're all nothing. How the fuck is it gonna take that long to get there? End the type with a semicolon. Okay. It was 1 minute too late. Okay, so we've gone over, what are they even called? Scoped enumerations. Cool. All right, more in a bit. Self-test today.